Let's see how we can use the CORREL function in Google Sheets. We have the CORREL function Google Sheet open, and it has the data template we require. In column A, we have the random variable, x, values. In column B, we have the random variable, y, values. In cell I1, we want to find the correlation of x and y using function, that is, we want to find the statistical measure of the relationship between x and y. And in cell I2, we want to find the correlation of x and y by calculation, using this formula, that is, we want to check if we get the same result as we get in cell I1, in cell I2, that is, we get the same correlation of x and y using function, and by calculation. To calculate the correlation of x and y by calculation, we need cxy, sdx, and sdy, which we will calculate in these cells. In cell D2, we will calculate the covariance of x and y, which is cxy. In cell E2, we will calculate the standard deviation of x, which is sdx. In cell F2, we will calculate the standard deviation of y, which is sdy. Now, to calculate the correlation of x and y, using function, we will first head to the I1 cell, then we will use the CORREL function, which gives the Pearson product moment correlation coefficient. It takes data_y and data_x as arguments. An example is shown. For our case, we will write equal to CORREL, data_y, is given in the B2 to B11 range. So we will write B2 to B11, comma, data_x, is given in the A2 to A11 range, so we will write A2 to A11. Let's close the bracket for the CORREL function. We see that we get the correlation of x and y using function as 1. The correlation between two random variables can vary from -1 through 0 to +1. If the correlation is -1, that means there is a perfect negative correlation between x and y, that is, the two variables vary in opposite direction. If there is no linear relationship between x and y, the value will be 0. If the value is +1, there is a perfect positive correlation between x and y, that is, the two variables vary in the same direction. Now, to calculate the correlation of x and y by calculation, we will first calculate the covariance of x and y, which is cxy, in cell D2. So, we will use the covar function. Data_y is B2 to B11, comma, data_x is A2 to A11. Let's close the bracket for the covar function. We get the covariance of x and y, cxy, as +16.5. Now, to calculate the standard deviation of x, sdx, we will head to the E2 cell, and we will use the SDEVP function. The values are the x values given in the A2 to A11 range. Let's close the bracket for the SDEVP function. If we drag this formula from cell E2 to cell F2, we see that the argument of the SDEVP function changes to B2 to B11, which are the y values. So we get the standard deviation of y, which is SDY. Now, to get the correlation of x and y, by calculation, we will head to the I2 cell. We will write equal to. cxy is calculated in cell D2, so we will write D2 divided by, open parenthesis, SDX is calculated in cell E2, so we will write E2 multiplied by, SDY is calculated in cell F2, so we will write F2 close parenthesis. We see that the correlation of x and y, by calculation, is also 1, the same as we got in cell I1, So, by using function or by calculation, we get the same correlation as 1. Suppose we want to create a graph of y versus x, so first we'll select these x and y values. Then head to the Insert tab. From there we will select Chart. In the chart editor, we see that the chart type is scatter chart. We will change it to line chart. From the Customize tab, let's select horizontal axis. And then, for minimum value, we will write 0, and for maximum value, we will write 11. Let's close the chart editor. We see that x varies from 0 to 11. As x increases, y increases, we have x, y, and y versus x. Also if x decreases, y decreases. If we check this value, we got the y values using this formula. Instead of this 2, if we give -2, and we drag the formula down till B11, we see that the graph is updated, as x increases, y decreases. So the x and y variables move in opposite directions, the covariance of x and y becomes negative, magnitude is the same 16.5, but it becomes negative. So correlation of x and y, using function changes to -1. And the correlation of x and y, by calculation, also changes to -1. Now suppose, if we have instead of this data, something like 5, 5, 2, 5, 5. And then the same data here. The graph changes, there is no particular relation between x and y. We see that the covariance of x and y is 0. Correlation of x and y, using function is 0. And correlation of x and y by calculation, also is 0. Let's change back the y value to equal to a, 2 multiplied by 2, plus 40. Let's drag the formula down till B11. We see that the graph is updated, so, as x increases y increases, covariance is updated to 16.5, and the correlation of x and y by function and by calculation is updated to 1. With this, we have successfully learned how to use the CORREL function in Google Sheets. Thank you for your time. Please like, share, and subscribe if this video was useful.